So now that we have the solids flow chart down, we can start using that to rank melting points of solids. What we're really ranking here is the strength of the intermolecular forces. And we're going to start with ionic compounds because those are going to call back to our first unit where we talked about ionic and atomic radius. So we're going to use our old friend Coulomb's law to consider this. If our radius is smaller, we are going to have an increase in our force. And if our charge is larger, we're going to have an increase in our force. So what we're really looking at here is we're looking at ranking the charge versus the radius. Now, as we go along the top of the periodic table, so going from left to right, our radius will get smaller. Radius goes smaller, right? And as we go from the bottom to the top, our radius will get smaller. So what that means is when we look at these, if we can generalize the radius, that radius trend, we can figure out which one of these are going to have a stronger intermolecular force. Likewise, if we have an increase or a change in the charge, we're going to have a difference in the force. So let's look at iron 2 chloride and iron 3 chloride right off the bat. Both chlorines, these are always going to have a -1 charge. But this iron here, this one is going to be a +2. This one is going to be a +3. So which one of these would have a higher melting point? Well, the iron 3 chloride would have a higher melting point. This would be greater because it has a higher charge. Great. Then let's look at NaCl versus Na2o, Na3n. Well, the sodium in each case has a +1 charge. But here we've got chlorine with a -1, oxygen with a -2, and nitrogen with a -3. And so in this case, our Na3n, that should have the highest melting point, and Na2O should have the second highest. Now if we come down here, NaF versus NaCl, NaBr, all of these have the same charges. So these are all going to be the same charge, right? All +1, -1. So what's going to be the determining factor here? Well, for these guys, it's going to be the ionic radius. If we remember our trend, fluorine, chlorine, bromine, those are all going to be right at the edge of the periodic table. We're going to have fluorine, chlorine, bromine. Each one progressively bigger as we go down. So the smaller the radius, the bigger the force. Remember, the smaller the radius, the bigger the force. So that means NaF is actually going to be the greatest force, followed by NaCl, followed by NaBr. Now let's combine those concepts. Let's look at copper chloride, copper 2 chloride, and zinc chloride. Well, in this case, we have a +1 versus a +2. So that means that the copper 2 chloride, that's going to have a bigger force. And the zinc is also going to have a +2. So which one of these is going to win out? Well, if we look at a periodic table, we're going to have in the D block copper followed closely by zinc, right on the edge. And so zinc is going to be a little bit smaller than the copper. And that lower radius is going to result in a stronger intermolecular force. So those are our ionic compounds. So we can compare ions using the charge and the radius. But what if we factor in some metals? Well, metallic bonding is going to be pretty complex and beyond the scope of this class to rank our melting points, to rank that force. It's going to have a lot to do with how many electrons are delocalized. It's going to have a lot to do with what kind of ions those metals can make. But it's tough to explain the pattern throughout the periodic table. And so when we look at ions versus metals, we're going to say that ionic compounds, are going to be close to the force of metallic compounds. So if you see ionic compared to metallic, you're going to say that their melting points, their forces are going to be close. And then you're going to be able to rank the ionic compounds based on what we just described. And then what we're also going to see is these are going to be fairly close to covalent network solids, okay? And covalent network solids, we will specifically identify them. There's not a clean way to figure that out when you just look at the chemical formula. So these are not going to come up that often. And if they do, we will identify the specific substance with a little parentheses like diamond or glass, something like that. We'll say what substance it is, and that's how we'll know that it's a covalent network solid. Okay, and all of these are going to be greater than, this is a sideways greater than symbol, than our molecular solids. But once we get into molecular solids, we can kind of generalize this as hydrogen binding is going to be the greatest, followed by dipoles, followed by London dispersion forces. And once we get into the London dispersion forces, then we're going to be looking at number of electrons. Okay? So once we take all of those factors into consideration, we can actually make some pretty solid rankings. If I've got a bunch of molecules, so if I take all of these molecules, I can actually make a pretty comprehensive ranking on what these forces are going to look like. NAF, Na2o, and Fe, those are all going to be my highest ones. My ionic bonds, I can separate those pretty neatly. Na2o, that's going to be my highest because it's got a higher charge. This is -2 versus -1. So it's going to be greater than the sodium fluoride. And that's going to be about equal to the iron. We're just going to say they're near each other. Now, those are going to be greater than all of these because all of these are going to be covalent solids. Now, when I look at H2O, I can see that that's going to have hydrogen binding, so that's going to be my next one. Then after that, it's going to be between HCl and HBr. Well, HCl, that's going to have some polarity there. That's going to have a dipole. And so when I look at HCl versus HBr, my electronegativity difference between HCl is going to be around 1. And in HBr, it's going to be around 0.85. And so if I look those up, then clearly HCl is going to need to be larger. It's going to have a bigger force. So now I can make a pretty comprehensive ranking of all of these just using a few little ideas.